Welcome to myprojectbazaar.com. Let me discuss about the process automatic detection of Exudates in diabetic retinopathy images. Let me discuss about the process automatic detection of Exudates in diabetic retinopathy images. Initially, the retinal color channels from the retinal images were separated. Filtering process is done. We are using Gaussian filter in order to filter the images. Then the images were enhanced using histogram equalization and normalization operations. Then for normal images, optical disc is segmented, and for the other images we are segmenting the defected regions. That is, for X-rays we are segmenting the X-ray portions, and for hemorrhages we are segmenting the hemorrhage portions, and for microaneurysm we are segmenting the microaneurysm portions. So for that segmentation we are applying level set segmentation algorithm. Then we are extracting the features from the images using local binary pattern. So the extracted features were saved, and we are training the database by extracting the features for all the images in the database. So the trained features and the test features were passed into the probabilistic neural network classifier. The probabilistic neural network classifier classifies the input retinal images into the four categories that become specified. That is a normal image, or X-ray affected, or hemorrhage affected, or microaneurysm affected. So these four defects were identified and the results were displayed. Finally, we are measuring the accuracy, sensitivity and specificity of the classifier, and the results were displayed. Thank you. Let me discuss about the flow of the process automatic detection of Exudates in diabetic retinopathy images. So initially the retinal images were pre-processed. So for pre-processing we are using Gabor filters. So Gabor filter processes optimal localization properties in both spatial and frequency domains. The impulse responses of these filters is created by multiplying a Gaussian envelope function with a complex oscillation. The phase difference of the left and the right filter responses to the estimator disparity in the stereo images. Then after that we are applying the segmentation process. Before segmentation, the images were enhanced by using histogram equalization process. So the color channels of the images were separated. Then histogram equalization is applied to each channels. The images histogram equalization process normalizes the each color pixels of the image. As a result of histogram equalization, color channel values of the image were equalized so that the images are much much clear color information. Finally, the color channels were combined. Normalization of the images includes that the average value of the three color channels are added to each color channels. This will result in the increase in the contrast of the retinal image, which clearly identifies the reflected or the brighter pixels in the image. Finally, the color channels are combined so that the images are used for further processing. Then for segmentation, we are using level set segmentation. Level set segmentation segments the images based on the pixel intensities. Normally, optical disc and the affected regions were brighter than the other pixels. The pixels that have high pixel intensity is found out by comparing the pixel values. The location where high pixel intensity identified were got. Those regions were blackened, and the other regions were replaced from the original color image. Then for segmentation, after segmentation, we are applying feature extraction. So for feature extraction, we are using local binary pattern algorithm. So LBP feature vector is the simplest one, creating the discreted in the following manner. So image is divided into cells. So for each pixel in the cell, compare the pixel of its to the neighbors, following the pixel along a circle, that is clockwise or counterclockwise. When the pixel center value is greater than the original neighboring value, rate is 1, otherwise 0. This gives an 8-digit binary number. Compute the histogram over a cell, the frequency of the number occurring. Optimize and normalize the histogram. Compare the histogram of all the cells. This gives a feature vector of the video. Finally, we get a feature vectors, and then these are scientific estimate features. Similarly, we are training the features and they are scientists training the features. Then these two features were combined and they are given to the probabilistic neural network. So the probabilistic neural network classifies the input retinal image into normal or exudate or microaneurysm or hemorrhage. So we are identifying 4 types of defects in the retinal images. Let me see the running procedure of the process. Automatic detection of exudates in diabetic retinopathy images. So if you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. So you will get a video which is required to run the program. So select the input image. So select any one of the input image that is given in the dataset. So we are going to identify microaneurysm, hemorrhages and exudates in the retinal images. So you can give any one of the images present in the dataset that we have given. So the images were selected, and then the channels were the the channels were separated, and then pre-processing is applied using Gabor filter, and the result is displayed here. Then histogram equalization is applied, then normalization is applied to the input images, and then we are segmenting the input image. So here OD region is alone segmented. Then we are extracting the features from the image. So for feature extraction we are using NPV feature extraction. So here the training image features were extracted, and this is a test image features. Then after that we are performing the classification. So for classification we are using probabilistic neural network. So the PNN classifies the input image as a normal image, and the accuracy, sensitivity and specificity values were measured, and the obtained values were plotted as a graph. So we are using probabilistic neural network. Please run the code in MATLAB higher versions like 2011, like that. In the lower versions these functions were not readily available. The code will not run, so please run it in higher versions. Similarly, we can also classify other images, like if we give any of the if we give some microaneurysm images. So we are performing the same process. We are segmenting the particular regions, and we are extracting the features from the images, and then we are classifying. So we are segmenting the exudates. We are identifying the exudates. So like that we can classify. We have given 4 categories, such as exudates, microaneurysm, and hemorrhages, and normal images. So like that we are doing the process. Thank you.